Good afternoon, and happy to see you are all for this key conversation today. And when we think South India, what comes to our mind first? Right? Bright sunshine and coastal humidity. Yeah. So most of the these tropics, we are seeing the impact of the cooling, and we are unable to maintain proper temperature in the data center halls. So the other side, in this tropic, when data center is rapidly growing, okay, we can unable to say, even we are unable to think how to grow in a small pace. The data center is growing. The digital transformation also is growing in this region. See, look at everything. How can we keep our servers cool, and how can we maintain the temperature for the data hall? That is the major challenge. Now you see, even uh, if you look at any major data centers, the problem is just cooling is the issue, and how to control the temperatures. So now we have a great panel today here. I welcome all the panelists today for the great discussion now. And we'll deep dive to the panels now, and I'll ask Siddharth Jain for the first question. What are the key design impacts we are operating higher chilled water temperature in the data hall, and how can we control that one? Over to Siddharth.
Okay, thank you, Mahendren. So you're saying what is the key impact of the higher temperature? So again, there are two aspects to this. Maybe I'll take 30 seconds more, and we can set a context to that and then discuss this. So if you look at a higher temperature of the chilled water, that's actually a great option to have when we are talking about liquid cooling, right? Because in the liquid cooling solutions, we are able to accept a higher temperature because the chipsets are happier at maybe a 30 or 40 degree centigrade water temperature as opposed to the 7 to 12 degrees that we were talking about in a typical air-cooled setup that we had. Now, it's a great leverage point because now what I can do is I can possibly go almost chiller less, right? Because I can just work on dry coolers. I need not run compressors. Now imagine all I need to do is run at the ambient of, let's say, 35 degrees, if that is what Chennai mostly runs at. So whilst that is obviously a blessing or a nice thing to have, we also need to understand that there is a flip side to this as well, right? Because we are getting this efficiency at what cost? Because now naturally when my temperatures are rising, right, I'm going slim or thin on my thermal margin that I'm going to have. In the good old, air-cooled, fan wall, or where we're using chilled water plants, etc., the room is reasonably cool, so I have thermal margin, so I can accept some kind of sloppiness, let's say in the operations or anything, at a certain temperature range. A small failure here and there I can handle with the excess buffer cooling that I have in the room, which I'm going to be doing away with. But again, I'm not trying to sound negative. I'm still supportive of the fact that higher temperature water is something that we should be looking at. We should be looking at more energy efficiency, doing away with the chillers, talking more about dry coolers. But we then need to be cognizant about that all these steps below that have to be designed at that level, right? Because now I cannot accept even a small, failure, a fouling of, let's say, the CDU or something like that. I don't have that room anymore. So that design below that is something that we need to be very, very cognizant about. So it's of course a great thing to have. That is where the future of cooling is moving to, and it's an ideal situation to have given the tropical climate of Chennai.
Great, nice insights. And how we can evolve further, and we have to make more sustainable and efficient way. We have to operate the chillers. We can get enough cooling. Great. So now I move to Dhananjay for how are we tropical cooling design handling this heavy workload is there in AI. How can we control and how can we mitigate this situation, Dhananjay? For you.
Hi, good evening all. My name is Dhananjay. I'm from Aggreko and I'm heading this business for data center for Aggreko India. So just to answer questions about what Mr. Mahendran sir has asked, how to mitigate this AI requirement. Now everybody is talking today AI, and that's because of the world is coming closer. The demand of software and the speed at what level everybody is traveling. So ultimately, the data center is the one hub which is connecting everyone. So to mitigate the cooling need, everybody is talking about to move towards the liquid cool, where the rack density is crossing. There is no thumb rule, but above 40 kilowatt, it says that you should move towards the liquid cool, so you can have the better PUU and the efficiency can be achieved. Where in general, the water has better capacity to transfer the heat than air. More than 20-25%, you can transfer the heat through water. So the best way to adopt the AI is to move towards liquid cool. No doubt, as we move ahead, there will be definitely challenges because it's a new technology. The liquid is going to come in contact with chips, and there are a lot of pipes. It needs to be run through pipes. So challenges is there, but that's what the currently industry is diverting, and we are seeing at the ground level, liquid cool is the next option which is getting adopted to see this. Yeah.
True, Dhananjay. So then net, we can think about the hybrid cooling model. Even conventional model is always, when we have some impact. Yeah, great. Thank you. And my next question to Vishal. So what are the key consideration we have to assume in mind of the designing of liquid cooling design, including liquid flow management or even any dielectric fluid? What is your view and perspective on that?
Yeah, so thank you very much for having me on this panel. So I'll start with where Mr. Siddharth left it, on the temperatures that we are achieving right now or have been there. So historically, if you see, even in the air-cooled chillers or air-cooled data centers, we had this 21 degree or 17 degree or those kind of temperatures we operated once upon a time. And now it becomes almost a room temperature. Imagine a future, fast forward maybe 5, 7, 10 years, I don't know what. There will be a topic of immersion cooling, where there will be a usage of hydrocarbons, which has a boiling point more than 200 degrees centigrade. So eventually, it will the graph will go upwards. We are somewhere in between, and that's where the immersion cooling, be immersion cooling, be liquid cooling, all these topics are of very interest in order to reduce the PUE first and then managing the thermal power. Coming back to the liquid cooling and the flow management that we are doing. So in the SFN side, so there is a facility side and there is a technology side. In the SFN side, there are a lot of variables. Some of the servers are under maintenance, some servers are underutilized, or there is no load condition, or for future capacity they have built in. And if you imagine the entire SFN, there is a differential pressure, there is a excessive flow, or there is a reduction of flow. Now, out of all these scenarios, how are you going to ensure that every single server is getting the adequate flow for each rack? Be it 42U or 52U, but there can be certain racks. One of the solution that that was developed along with one of the leading hyperscaler is having the differential pressure across the server. So I don't manage the pressure or flow in the SFN, in the header of SFN, but we can start managing that on the server side. So each server is, you unload, let's say 30% servers, 40% servers, but you're getting differential pressure and modulating the flow the way it is required. This is critical and very, very essential, because what I have seen out of my limited experience in some of the projects is temperature is irrespective, but pressure is very, very important in the SFN. And that's where the flow management, particularly in the SFN side, is very, very critical. One of the way is managing the flow across each rack. Other way is bypassing some flow and managing the heat loads. So it depends the kind of, and that's where there are types of CDUs like panel mounted or floor mounted, and they cater to all these various requirements. That's where I see things will move on.
Nicely portrayed. So we are facing a lot of operational and the other related issues for the site front, because then I want to ask some certain operational related question with Dhananjay. How to mitigate the emergency cooling whenever operation once fails or standby needs to come? What is your opinion, and how can we mitigate that situation and portray it clearly for the site level?
Thank you for asking that. Though data center is always designed with the redundancy, and it's a stringent redundancy based on the tier we see n plus 1, n plus 2, n plus n. But still, based on the end client's agreement, which we call SLA, still there has to be a plan in case of existing package goes off. One of the chiller, one of the generator goes off. So globally we are doing, as like Aggreko, there is a contingency planning where we go to the customer side, we understand the power and cooling requirement, and we see in case one of the power goes off, whether it's a generator, whether it's chiller goes down, we understand it, we do a pre-study, and then we make an agreement with the customer. So whenever requirement comes, we just supply the equipment. So there is a clear-cut understanding at site requirement, where it has to be delivered at the site, where it has to be connected, and what the role and responsibility of the two parties, which always becomes a challenge in case of the emergency. Most of the times when emergency comes, then commercial terms come into picture, then we need to do the study at site. But contingency is one of the services where Aggreko is leading, and we are having a tie-up with many data center players where we study and then we make it available as and when they're required. Yeah. So that's
So next one I want to ask Vishal again. So we are facing a lot of design issues at the site level. For whenever going and developing the design initial phase, we are facing lot of challenges. What is your opinion, and what are the key characteristics for open compute project, and how can we mitigate the situation? How can we align more in the projects?
Yeah. So if you ask me personally, the OCP is something which I will support, because that's something which is not new, but because they have developed certain server cooling and other things that has come into discussion. It was originally started by Meta way back in 2010 or 13 somewhere. And since then, there is a thought process that, okay, let's make this open participative kind of thing. And those who are not aware about OCP, you can just Google it and you can be a member or part of it. They have some frequent calls every time, and you can join in, select the topic, be it be liquid cooling, be it be chip design, be it be CDU. There are certain topics. And they are trying to bring some standardization. They are trying to bring some design which are constraints right now. They are trying to standardize certain things. So there are OCP racks, OCP servers, which are designed with certain airflow, which will take care of that flow management and other things. And they will certainly cascade their overall initiative into other phases. And that's where I see personally initiatives like OCP and standardizing the things will certainly help for scalability of the data center. So right now, because we are going through that learning phase, when we started, what it was, what right now, and what it is going to be, it's very, very different. But on the way, once you start standardizing things, your learning curve becomes very, very easy, and scalability becomes a very easy topic for managing.
Very great insights. Thanks, Vishal. So I want to ask Ashish Jain again. What is the existing way to upgrade the cooling? Now we are seeing heavy impact of AI workloads and heavy impact in the workload flow. So what is your opinion and your suggestion on that area? How can we accommodate heavy workloads in the existing facilities and to upgrade the old facility?
So that's a great question, Mahendren, because this is something I think a lot of people would be talking about and asking. Now, firstly, at the risk of sounding negative, I'll tell you that upgrading existing facility for AI, all this can't fit in the same line, because I think the question is, what is the baseline where you are today, and from there, where are you upgrading to? So let's say if you are at the traditional 5, 8, 10 kilowatt, and you want to upgrade up to, let's say, a 50 kilowatts at the outer limit, at the higher limit, 40 to 50 kilowatts, that is easy, right? So the question is, how easy it is. So that is easy because I can add in some RDHX units, I can throw in some in-row cooling solutions, I can have some, basic hygiene, cold aisle, hot aisle arrangements, some, airflow boosters, so on and so forth. So doing all these things together, I can get to the 50 kilowatt mark. But once you want to cross over, so I think that is where the question is about AI infra, which I'm assuming obviously crosses that 50 kilowatt mark. it's no more a question of an upgrade, because now it's almost boiling down to a rebuild of that facility, right? Because here now it's no more a cooling problem anymore. The CDUs, all these things you'll import, you'll bring it, you'll put it there. The cooling is not a problem. My problem is the entire facility now. Because do I have the power to support that particular infra that you have brought in? Do I have the floor loading capability to support that infra that you are planning to bring in? Right? You are going to be bringing in now water into your, the white floor space, into your racks, so to speak. So now there is a complete change which is happening. So we're typically talking about a rebuild and not like a upgrade that we're doing to a facility. So short answer, up to 50 kilowatts, yes, you have solutions, easy, doable. Anything beyond that, it's virtually like a rebuild, or I would rather suggest going greenfield for that. So the challenge with AI is not for the new facilities, right? Because we are accommodating for the primary side, the secondary side, the technical side of things, or the SFN, whatever you want to refer to it. The challenge is with the existing facilities. It's not that, we are going to bring in something and we are going to upgrade that to the, AI, to accommodate AI there. So that is my take, which I feel that, this sentence itself, can't coexist talking about upgrading an existing facility to an AI grade.
This is more insightful, and it is more helpful for existing data center facilities developers. They can think of and they can build more capacities to cope up for the new AI workloads, I believe. So that now I can move that next one for the reliability point of view. Okay, again, Dhananjay is there. They expect. How are the reliability and redundancy evolving with liquid cooling in air-cooled facilities, Mr. Dhananjay? You can put your point, very.
Thank you. I think it's a critical questions because we are still learning on that part. But what industry standards they are going with, they are going CDU, which obviously has come into pictures, which is like, making two systems separate, primary and secondary side. So we have seen clients, they are going with the N+1 redundancy for CDU. Some of the location, there are new things are getting evolved, like dripless kind of coupling, where you can separate the server, liquid cool server, and you can offload that in case any working has to be there. Parallelly, there is a mixed kind of cooling in the data hall, where air cooled like 20% and 70% or 30% or 70% liquid cool and air cooled combination can be done. So it's a still, I will say, a learning. Maybe on paper we can say we can go in with redundancy, we can add the CDU, but still in terms of the cost, in terms of how to manage its complete infrastructure, is still learning phase. And I think to have the clear answer, maybe we need to wait for another 1 year, where we will be seeing many projects which is under execution will be running, and that will give a lot of answer to us in a genuine way.
Very, very nice, Dhananjay, and have clearly portrayed, and the answers are very clear to that point. Yeah, thanks, Dhananjay. So here, Vishal, I want to ask one more last question with you. As a designer point of view, if you are adding existing data center, right, existing servers are very packed. Now we are thinking about AI, additional workload and software. So what do you think about that? How can we, mitigate in a higher, higher level? How can we think this one?
So again, for existing, it is like Siddharth said in his presentation, like 6 to 8, 10 kilowatt was the thing, and now it is going. So it is mainly on the what GPUs they are going to use, how things are moving forward. That is very, very critical in terms of heat management point of view. When they talk about liquid cooling, it's like only liquid cooling and nothing else is there. That's not going to be a scenario. See, air cooling is still being a part of it. And some of the aspects of existing data hall or data center may be used. I'm not sure on that side. But certainly when you are using the higher GPUs or higher capacity racks, you need to create a separate infrastructure for cooling those things.
Nice. So now open to audience for the any key questions you can ask. Please free to ask. Then panel, please. Anyone, please? I think it's very hard time we are conducting a panel, I believe. So, great. So, with the closing note, we have to think air cooling to liquid cooling. And if you think of the infrastructure led, we have to move to optimization based and resource based to resource efficiency. That is the key takeaways I have taken from all the panelists. And thanks for the timing and for answered for all the questions. Thank you. Thanks for that.
Thank you, everyone.